Let's talk about Python data types. On the low level, all data and variables in the computer are represented with binary digits, 0 and 1s. On the application level, however, we need different data types and ways in which data can be operated with respect to the problems that we have. We need the basic building blocks or primitive data types to construct more complex data objects. Ultimately, whatever computation we can perform is dependent on the data types. For example, characters and strings can be sorted and concatenated. Integers and numbers in general, on the other hand, can be added, subtracted, and multiplied. The notion of abstract data type represents a logical description of data and related operations on the data. It is an abstraction or a blueprint of the actual implementation, which will be based on programming constructs and primitive data types. There are built-in atomic data types or classes in Python. Numeric types such as int and float can be computed with operators such as division, exponentiation, modular, among others. Numeric values are ordinal data, and you can use relational operators such as less than or greater than to evaluate and compare different values. The result of a relational expression is either true or false, a Boolean type. There are ways in which Boolean values or Boolean expressions can be combined. Using and, or, and not, you will be able to construct any complex conditions. You can pause here and test some of the operators, change some of the expressions here, and run them again to see if they meet your expectation. The bool class is for the Boolean data type, for variables with either true or false values. You can see from example here, a Boolean type is either true or false. And you can combine them using operators such as and, or, and not. Here you see the result of an equality and inequality comparison is also a bool value. For example, 5 equal to 10 is false. And it is true that 10 is greater than 5. So again, you can combine multiple conditions using the logical operators. Again, you can change the expressions and test them for yourself to see if logical operators such as and, or, and not make sense. So far, the data types are associated with single data values, such as a number, a Boolean value, and so forth. In data processing, we often need to deal with the collection of data values. There are multiple types of collection data. You may have an ordered collection such as a list, a sequence of characters that is a string, and data tuples. In other situations, an unordered collection such as a set or a dictionary might have been what you need. A list is an ordered collection of 0 or more data objects. An empty list without data is constructed by a pair of square brackets. By adding values to the brackets, we can add new data to the list. Multiple values are separated by comma. In Python, a list can be either homogeneous, such as those consisting of data of the same type, or heterogeneous, that is, data of different types or classes. This makes programming flexible as well as dangerous. To access an individual element in the list, you can use an index to refer to a specific position in the list. The index is the integer starting from 0, which references the first element in the list. 1 refers to the second, and so forth. You can get the value of an element to read from it, or you can also assign a new value to it using the assignment operator. So in the example here, we can have a list of names and they are homogeneous. Every element is a string here in the students list. You can also have data of different types in the list, such as the mixed variable, which has strings as well as a bool value and a number. To quickly create a list of many data values, you can simply multiply a list by a number. Here, for example, you have a one element list, 30, and when you multiply it by 12, it becomes a list of 12 items with the same value. You can then change the value of a specific item by using the indexing we discussed earlier. For example, M square bracket 1 references the second item in the list, which can be used for the month of January. For a list variable such as X, here are some of the functions. For example, to append a new value to the end of the list, to insert a new item at a particular position, or to remove an item at the end of the list, or to remove it at a particular location, to sort the items in the list, or to reverse the order of the original list. In the example here, we first have a list of 6 weekdays in the variable week. The week.pop is called to remove the last item on the list, which is the Sabbath. And with week.append, we can then add Saturday to the end of the list. And using insert method, we can insert a new day such as Tuesday at position 2, which will be placed before the existing Wednesday. There are a number of functions related to the list data type. For example, the range function defines a sequence of values in a range, which is an iterable. The list function constructs a range of values based on an iterable. And the len function returns the number of items in a particular list. So here range 10 creates a range between 0 and 10, but does not include number 10. A list can be created based on this range, and the result of it integers from 0 to 9. A string is essentially a list of characters, or a sequential collection of 0 or more letters, numbers, and other symbols. Because a string is essentially a list, you can continue to use functions such as len for the list, and the same indexing mechanism to access individual items or characters in the string. There are functions associated with the string class. For example, you can use the find method to return the index of the first occurrence of a particular item you are looking for. You can use the lower or upper methods to convert the string into lowercase or uppercase. You can also use the split method to split a string into substrings with a separator. In the example here, you can use the find method to search a string and find out where a substring such as P appears first in that string, in the name. You can use the split method to divide the full name into first, middle, and last name with a space as a delimiter. A tuple is very similar to a list, but it is an immutable sequence of data objects. That means it cannot be changed once constructed. So it creates less overhead and is more efficient than a list. And the values of a tuple are delimited by commas in parentheses. So a tuple behaves like a list. But with the code here, try if you can uncomment the last statement and see if you can actually change the value in the tuple to see what happened. In fact, it's going to give you an error saying that you are not allowed to do it. A set is an unordered collection of 0 or more immutable data objects. Every item is unique in a set. So that means there's no duplicate. An empty set can be created using the set constructor or a pair of empty curly braces. Values are delimited by comma in the curly braces. Here is an example to create a set of chess pieces. And you can see that in the end, only unique elements are preserved, even though we enter multiple knights and bishops in the set. There are operations you can perform on sets, such as to take the union of two sets to find out the intersection or what's common of two sets, or to compute the difference between the two. So with built-in methods of the set class, you can easily find out between John and Mary what's in common, what's the joint skill set, or what unique skills Mary has. A dictionary is an unordered structure of associated pairs of items. Each pair contains a key and a value. Pairs are comma delimited in curly braces. Each value can be referenced using the key in the square bracket. A dictionary is very useful and highly efficient to keep track of data associated with unique identifiers. The example here keeps state population data, and you can quickly look it up using a two-letter unique state name. There are built-in methods of the dictionary class in Python. For example, you can use the keys method to return all the keys in the dictionary, or the values method to return all the values in the dictionary. In this example of vote counting, every time we see a vote for one candidate, we can add 1 to the candidate's key in the dictionary. However, a potential problem may arise when a key does not exist yet. The get method is useful when certain keys may not have existed in the middle of a counting process. Paul, for example, has not received a vote, so his name is not in the dictionary yet. So when you use votes.get Paul 0, it will return 0 if the key is not there yet, so we can add 1 to it. Without the default value 0, the program will trigger an error when you try to add 1 to a null value.